The last time we were dealing with the realistic MG-1, what happened is that we had a problem with the polyphony section where the G key gives us a bum note. Okay, so I put the chips, the divide down chips back in, and I have so on and so forth. You know, the G is not behaving properly across the range. So what we needed to do is verify what path did the G take. And you know, you can look at this. If you don't have the service manual, you can take a look and you notice that, well, G here goes to red wire here and it terminates down here, and this G over here goes to this red wire too and terminates there, and then you have another red wire and same thing right in this spot. And you look down on the printed circuit board, it even says G. So if you have your service manual, which is online, you can go ahead and take a look at the operation. You say, okay, well, you know, we've got, you know, this problem, and you start looking at it, but read from the beginning, because that's basically what it's going to tell you right off the bat how this thing works. So we'll get to that page, and it talks about your polyphonic tone generator. The polyphonic tone generator consists of a high-frequency master oscillator U2001, top octave synthesizer U2002, and dividers U2003 through 2006. Okay, so we have already replaced the 2003 to 2006 because we were having problems with the keyboard across the range. We had notes here, there, and elsewhere that were just not responding except for the top octave. We couldn't, you know, this over here is working, these two down here were not working. So we replaced those, and that's fine. Now, continuing, in a simplified operation summary, the high-frequency oscillator, where'd it go? Produces a 125 kilohertz square wave. The top octave synthesizer divides the square wave down by different ratios to generate the frequencies of the top octave on the keyboard. The rest of the dividers divide the top octave frequencies by factors of 2 or 4 to generate the rest of the pitches on the keyboard. Okay, so now we have an idea that 2002 is going to be where we need to look at, because the master oscillator is there because we're getting notes. It's the 2002 that separates that down to your 13 notes here. This is a 13 note what is it called here again? It's the 13 note top octave synthesizer. I'm thinking generator, but it's the same thing. Top octave generator, top octave synthesizer is the same thing. 13 notes. Those are the ones that this is going to take care of. Now we take a look at the board at U2002, and we see in the notes. Actually, we'll go in here and we'll just take a look and find the part for 2002. So we get in here and we take a look at the ICs, integrated circuits, and it says U2002 is an M083 chip made by SGS, and that's the supplier part number, which is not going to be available by anybody at this point. So you have to cross-reference what the M083 is. And when you look at the board, there is no M083 on there, so you have to look at the certain page over here that says, hey, this is going to be the U2002 right here. It says U2, but it's the same thing. It's U2002. This is the chip right here. And corresponding to that, you have this chip right here, which is the AMI. What is that? It's the AMI S50243. So you go on the internet and look up that part, and you can't find anything at all, even though it's there. So did someone change it? I don't know. So take a look at this one here. It's the same part. The same part is here on this one. It's the S50243. As a matter of fact, it it's exactly the same. So you have to do research. It turns out that the part is S50240, and it's the 13 stage TOG or TOS. Top octave generator, top octave synthesizer. So what happens here is that I take a look at my meter, I plug it in, and when I take the readings of these guys down here, it turns out, well, the lower octaves are producing the correct voltages that we're expecting to see. You know, it's about 6 volts, and then this one over here, which is going to be number 4. It doesn't have a. It doesn't. It starts. Let's see, R28, R38, and then we don't know what that one is right there. Nevertheless, we get to that spot, and we look here, and this is what we have. G consists of these 3 resistors here, and it goes over to U5 or U2005, and it goes into pin, let's see, pin 16, 15, and pin number 2. So when we trace back this, pin number 2, you see that it continues from here all the way back up to 2002 like we were discussing. So the master oscillator comes over to this right here. This generates the 13 notes, and this happens to be G. Pin number 10 is G. Pin number 10 travels down here, it comes over here, hits pin number 2, and it also parallel continues to this network here and then hits the keyboard where the red wire is going to be, and it goes straight up to right here. So that basically feeds this, but it's parallel, but at the same time it reads it, and it divides it down into your 2 and 4 right down here, and again right over there. So then you have it repeated, replicated, right there, and again right there. Ultimately, this is the source of our problem. This chip is defective at that pin, pin number 10. What do? Well, it's not a discrete component. You have to, it's an integrated circuit. You have to replace it. So you go online and you have to find it, and they're kind of pricey. But we know that we're going to be able to fix this, and it'll come back to life. Right now, yeah, you can't really play the polyphonic section, but what you can do, in the meanwhile, is turn off your polyphonic section, turn on your tone sources 1 and 2, and you still have your synthesizer available. So as long as you can live without that right now, we're gonna do fine. Okay, so basically what we're going to have to do now is just wait until we get that part. And for me, this can be a couple of weeks because I'm going to be out of town. And when I do come back in, what I'm going to do, the first thing is put a new socket right here, machine socket. We're going to save that part just in case. We'll use it as, you know, sometimes things come back, they probably won't, but we can use it to diagnose other parts down the road, just to verify if that part is working or not. We don't have to dispose of this just yet. That's going to be saved. Don't worry about that. And that's basically it. So the next video you'll see is when I work on that, and we will have this completed, at least for that section. Next after that, we're going to work on replacing all the capacitors, electrolytic capacitors, and maybe anything else needs to be done at that point.